Assalamualaikum warahmatullahi wabarakatuh. So we move to the next chapter, chapter 11, which is the formation of solid. So in this chapter, we're going to discuss about the process how can solid they form, or maybe some solid material can have this elastic behavior before it completely deform or break. So we all know that elastic behavior is actually the tendency of an object or any material to return to its original shape or size after the force applied is being removed. Okay, so that is elastic. We can only think of rubber, sponge that will back to its original state after the force applied is being removed. So imagine this one solid material here. So we have this one wire. So imagine this is the wire with the original length of L0, and then there is force applied at the end of the wire that will cause the extension E. So meaning the wire will extend by an extension of E, maybe some small length there. If let's say the force is removed, maybe the wire can back to its original length, which is L0. If let's say the force is sufficiently large, maybe the wire will have a permanent stretch, it will not back to its original length. So that is the process of deformation of solid. Okay, so this behavior of deformation of solid usually discussed in terms of strain and stress. Okay, so we are going to discuss about stress and strain for tensile and compression force that is acted on the solid material. So let's distinguish between stress and strain in the table below here. Okay, so in terms of definition, stress is the ratio of magnitude of external force, ratio of force to cross-sectional area where the force vector should be perpendicular to the cross-section. Okay, so kalau kita tengok dekat diagram dekat atas ni, okay, if you can see force here, that is the area. So the force applied is 90 degree to the cross-sectional area. So it has to be 90 degree perpendicular to the cross-sectional area. Let's say we imagine the material is a cylinder. Okay, so here is the cross-sectional area. The force applied should be 90 degree to the cross-sectional area, either at one end or the other end. Okay, so that is stress. So in terms mathematically, we can simplify the formula. Stress as symbol of sigma, okay, small Greek letter sigma, force applied over area, cross-sectional area. It has to be cross-sectional area. So for cylinder, the area will be circle. Okay, so for the wire is shown in figure 11.1, the cross-sectional area should be the area of the rectangle. Okay, so in terms of unit, I think you all know what is the unit for force and what is the unit for area. So stress should have the unit of Newton, because force we have the unit of Newton, and area is meter square, and then the unit for stress, it will be Newton meter negative 2. Or we can write this unit for stress as Pascal PA, the same unit as pressure. Okay, so since force and area both are vector quantity, so end up kita punya sigma ataupun stress, it will be scalar quantity. Okay, so kalau tengok daripada formula, sigma stress ni, stress is actually depends fully on amount of force. Okay, jadi dia punya relation is directly proportional to the force. Sometimes stress ni kita boleh juga panggil as a force. Okay, so next adalah strain. Strain shows the ratio between the change in length between the original and the extension length. The extension length after the length is being extended. Ratio between change in length to its original length. So maksudnya dia adalah extension over L0. L0 as the original length. E adalah berapa banyak dia dah extend. Berapa banyak dia stretch, so kita kena kira berapa beza tu. And the symbol for strain is epsilon. Okay, E epsilon lah. Okay, so macam mana nak cari elongation ataupun extension ni? usually kita akan ambil L minus L naught lah. So L yang after they being stretched minus with L naught, kita akan dapat lah kita punya extension E ini. So L naught adalah final length, and E and L naught kita mesti ada unit yang sama. So the unit will be cancelled out, and up kita tak akan ada unit untuk strain. So it has no unit for strain, dimensionless. Okay, so strain also is a scalar quantity. Okay, dan selalunya the result of stress, okay, the result of force daripada stress tadi akan menyebabkan berlakunya strain. The result of stress will cause strain to be occur in a certain solid material. Or we can simply say that strain also a measure of the degree of deformation. So kita boleh tengok berapa banyak, how much it has been deformed from the extension of the extension in length. Okay, so itu adalah perbezaan antara stress dengan strain. And then here some of the example of forces that acting on material. So kita ada tensile force, di mana force yang applied tu adalah opposite towards each other. Dia akan cause an extension, ada extra length dekat situ, dekat sini. However, for compression, of course, the name dia akan cause the object to be compressed. Okay, jadi that's why force dia opposite, tapi dia ibaratnya compress the object. It will cause the length will become shorter compared to the original length. Okay, so itu beza tensile force dengan compression force. Okay, tetapi ada juga case di mana kita panggil dia adalah bending, di mana that is the combination of tension and also compression. For example, shown in the diagram below. So kalau ada bending force dekat sini, dia boleh menyebabkan ada part yang berlakunya tension dan ada part yang berlakunya compression. Okay, so itu adalah some of the example lah untuk kita faham apa itu tensile dan apa itu compressive stress ataupun force. Okay, so let's look at example 1 here. Okay, there's two question. There are two question in example 1. The first one A, a wire originally 2 meter, that is the L naught, 2 meter long, suffers a 0.1% of strain. So dia bagi percent, strain dalam bentuk percent. Calculate its stretch length. So question asks to calculate E given L naught, and then this is actually E tapi in terms of percent. Okay, for question A, your E is 0.1%. So percent is actually over 100 lah. Okay, so ini adalah nilai E yang sebenar, E epsilon for the strain. And then L naught is given, which is 2 meter. They want us to calculate the extension. So from the formula of strain, it's E over L naught. So just simply substitute the amount, the value of strain. And then E, L naught is 2. So you can simply get the extension here. And the unit should be meter lah, because the length naught is in meter. Okay, for question B. A length of copper of square, a length of copper of square cross section area. Okay, so dia punya area, a cross sectional area is actually square, and the material is a copper, measuring 1.0 millimeter by 1.0 millimeter. So that should be the cross sectional area, square kan. Okay, so for part B, so that is the cross sectional area of square. Imagine macam dalam diagram 11.1 tadi, mungkin wire dia berbentuk apa kita panggil ni kan? Somewhere like this lah. Okay, so the cross sectional area is 1.0 mm, 1.0 mm. So we can calculate the area here is stretched by a tension of 40 Newton. So force mesti 90 degree to the area. So ini area 90 degree. Our force ataupun tension is 40 Newton. Calculate the stress in PA. Okay, so stress punya unit adalah sigma, force over area. So dia minta kita cari stress, force is given. And then kita punya area, kita kena carilah area ini. 1.0 convert to meter. Area mesti square lah, ataupun 1.0 exponent negative 3 times with 1.0 exponent negative 3. Okay, point Okay, so end up kita akan dapat jawapan dalam unit PA. Boleh juga tuliskan unit dia NM-2. Okay, so itu cara untuk kira stress by using the force. Cuma kita kena ingat force tu mesti perpendicular to the cross-sectional area. Sebab sometimes ada juga diberi force in this direction. Okay, so kita tak boleh gunalah force ni. Kita mesti kena ambil force di sini. Kita kena tengok mana cross-sectional area dia. Okay, so alright, so itu saja untuk first part of the chapter 11. Thank you.